of course, I mean, and this does not work very effectively for their case. For ACAS, this does not work very effectively. But the point is that you can decide your parameters to find out how much will you abstract. Correct. So you may abstract only so much that you have see. There is always a preference in abstraction. So if you want to abstract, there is always a preferred node. Okay, so you can abstract only so much that you have some, let's say, you have only some 8 neurons in every hidden layer or some such thing.
No,
So you can abstract
parameters can be used, but
at
you
that
cannot,
level.
with any good information, say, in terms of number of nodes that you want to merge, etc., you have some control. Okay, but because that determines the size, but there is no good criteria to say, merge these two or as against the other two when there are choices available. Correct. So that
Correct. So that
kind of thing
criteria
is
is
not.
not there. But correct. So that criteria is not there. So in the paper, they had defined such a criteria by selecting a set of points and finding the result for those points, and then they said that, look, we will do any abstraction that should not change those results. If it starts changing those results, then we will not do that abstraction anymore. So you can gain a semantic parameter by making some such choices. But it's not important that that this has to be done. In particular, for their experiments, this was not very effective. For a different domain, it can certainly be effective. I'm not saying that this is a bad choice in general.
Yeah.
But the point is that there's some liberty there that one can exploit. If you want to have a semantic parameter, you can define one. The syntactic thing could of course be to limit the number of neurons to some number.
Yeah, just one more thing. So during refinement, can you not use the counter example somehow guide you which ones need to be refined?
Oh, no, it was a counterexample guided refinement.
Yeah.
So the refinement that we presented was a counterexample guided refinement.
Correct. So it does the refinement process itself does select which ones to.
Correct. So, correct. So both the abstraction and the refinement select what can be abstracted or refined. So in that sense, it is not just any neuron. You select the one.
Okay. So let's go. So I have selected some order in which. So Sahil and Zubin.
So Kapil, does that answer your? So, sorry, sir. Sorry to interrupt. So Kapil, does that answer all your questions?
Yeah, so basically we need to decide how much abstraction we should do, right? Means we did not do the approach like I described in the Segar paper. It's like we can just manually choose what level works the best.
Correct. So for different properties, different kinds of abstraction would work.
Okay, yeah.
And roughly the size of the abstraction should be something that the SMT solver can handle.
Okay.
Correct, because we are not implementing the reluplex algo, so it is essentially the SMT solver which will be used for verification.
But the merging, etc., has to be done by hand, is it? So there is no.
Yeah, no, the verification has to be done by the Z3.
No, the verification is done by Z3, but when you merge two nodes, that process of merging.
Correct. So this can it can either be implemented. I think it can be implemented. It's not such a difficult.
Yeah, so it has to be transformed somehow from one. The steps of merging and refinement.
Correct. So it will be good to have a procedure called merge and abstract and refine, these two procedures, which can take a neural network and the refine should additionally take a counterexample.
So that is something that you have to do, because if you have to do repeatedly merge and so on. So
Correct, correct. I think it can be done, and I don't think it's a complicated thing. It's a fairly simple procedure.
Okay. Any other questions? Yeah, I kind of looked through the proposals myself, and I've chosen some order in terms of where I had most questions about. Okay, so what I will do is I will. So based on that, I want Zubin and Sahil to go first. So let me make you the co-host, and you could. Yeah, so you're the co-host now, so you can share your screen and start talking. Basically, what I want is you start with your showing your proposal to just refresh our memory and address the main thing. What the problem is. How do you generate data set? How do you train? What if, and in your case, there was a question mark about what exactly can you actually do in terms of verification. If you have thought about that, or what are the other challenges that you have, and finally, what the status is, what you have implemented, what issues you're facing, technical issues, and what your uh, plan is towards completion. So these are the things that I want you to address in the thing. And then we've all read your proposals, and we may have some questions about. Okay, so go ahead. Just flash your proposal first.
Okay. Can you see my screen?
Momentarily, I saw, but now.
Is it visible?
For me, it is not. Yes, it is visible. Go ahead, please.
Okay, so we want to synthesize recursive programs given a specification and the type. So that is our problem statement. So there are already systems that do this, but at lots of points they need to make arbitrary kind of decisions on uh, what branch to explore first. So they work basically by enumerating all programs which satisfy the specification, but uh, the order in which they consider programs, that can be the difference between terminating successfully or not terminating.
So right away, I have one question. So there must be some boundary in the thing. So now here, replicate is, where is the specification? This is giving a type, I understand.
Yeah,
So
so that specification is this.
yeah,
That
the specification is this condition that
yeah,
you have here,
yeah,
correct? And you
yeah,
can make this as complex. You can have any arbitrary equation there, correct?
yes,
Any
yes,
arbitrary expression, which
yeah,
means the specification is given as a closed form.
yeah,
Uh, that it is supposed to, the closed form expression, correct?
yeah,
For the results.
yeah,
Mhm. But correct. Okay, now here this is and then it has to, since it is a function on length. Now, what are the things that you can use? I mean, if you're talking
so
about functions over on list that manipulate
yeah,
list, mostly you will require some quantifiers there. Okay, if you
yeah,
want to say add one to everything. Okay, every element
Yeah.
of a list. So what is the
So there is a restriction. So the function that you can use over here are things called measures. So over here we're defining a type for a AVL tree. Uh, and the functions that we can use, we can define ourselves, and we have to define it like this. So we define a measure, balance factor of a tree. So the balance factor of a leaf is 0, and the balance factor of a more of a node is the height of the left subtree minus the height of the right subtree. So these are the things that, so these are all user defined, and these are the things that you can eventually use in the uh, specification. So for empty, we're using two measures, height and keys. So keys is basically the list of elements in the tree, and height is this measure defined over here. So the height of a leaf is 0, the height of a node. So these are all again recursively defined. There are some syntactic restrictions on what exactly, what kind of measures you can define, but in general, you can define them recursively.
so these you have using these functions you have to give specify the constraints on what your output
Yeah,
uh, list would look like,
yeah,
correct?
yeah.
So
So
suppose you want to do summation of all the elements. Is that
yeah,
possible?
yes, that is possible. So you'll,
How would you give me an example as to how
so
you
I'll just,
specify?
so if we sum, let's say it's AVL of int over here, because it's not some arbitrary thing. So so summation of a leaf is 0, summation of uh, some more complicated tree is x plus sum of L plus sum of R. That's, now you can use sum in your specification. So h is the height of the tree, which is irrelevant for the summation. X is the element. L is the left subtree. R is the right subtree. So you just
So in some
sum
sense,
over them.
kind of specifying the recursive structure. You're giving information about the kind of recursion that you have to
Yeah,
use in here.
yeah.
Okay. Yeah. So I understand. This is much like, yeah. So, uh, okay. Okay. So some amount of information is available. So given this, so you want to, your synthesis procedure has to complete, give a valid recursive definition
Yeah.
for the thing that
Satisfying.
doesn't use these functions or can use these functions as well.
So it can use these functions, but yeah. So it can use any functions in scope.
Right. But if it uses these functions,
So that's where,
would it be trivial? The resulting thing?
no, because you can have complicated specifications, right? So over here, like say you have insert. So insert is a very complicated specification. It says uh, uh, the height of okay, yeah, you're specifying that the height of t is less than the height of the output. And the height of the output is the height of the output is the height of the input plus minus 1, and the keys of the output. So underscore v is an implicit variable standing for the output, is uh, the value you gave y plus the keys of the input. So you're saying the keys of the output have to include the keys of the input. So these can be arbitrarily complex specifications. So
What are keys?
so keys are all the elements in the tree. So you're saying that the output height has to be either equal to the input height or one more than the input height.
Okay.
And the keys of the output are the key is in the input plus this y that you have supplied as
Yeah, but it doesn't
first
say
one.
where you're supposed to insert, no?
No, it doesn't say that. Yeah, so
Hmm.
that you have to synthesize yourself. So this is the specification, and then
Hmm.
uh, this
So
is
suppose that you have an ordered list and you want to insert it such that the order is preserved. How would you say?
yeah. So you would define mm, yeah. So uh, you define a new kind of list which captures the list as ordered. Okay. So you
Mhm.
have two constructors. You have nil, which is the empty list, and you have another constructor cons, which takes in x and some tail, and the tail has to have elements greater than equal to. So all elements in the tail have to be greater than equal to x. So this refinement is over here. So this by construction is a type of ordered lists. So you can't construct a list of this I list type without it being ordered, because otherwise this constraint will be violated, that the head of the list is less than or equal to any element in the tail. So we're given this refinement, and then insert would be specified like this: given an x and an xs, you construct an ordered list such that the elements of this list are precisely the elements of the input list, with and one additional element, which is this x that you were supplied.
It looks like more like you're specifying it as some kind of an inductive relation, right?
So over here, so the ordering we're specifying as an inductive relation, but
Mm.
the insertion property is not inductive.
Mm. Mm. Uh, so your synthesis problem, I think some information about that has to be included as a refinement to your proposal, because the boundary of your synthesis problem is is not specified as part of your proposal. Okay, so so the questions are, these are the kinds of questions I had, because this can be very open ended, and so are you dealing with synthesis given a set of predefined functions so that your specification is limited, or you can add you can add your own functions to that library that you just now showed, and you could have the thing, I guess. So then you probably have to have more tactics, etc. So what is the scope of your synthesis problem? Okay, the scope of the kinds of specification that you can actually write. That is one. Number two, then your proposal is saying something like you will have to select some kind of sub goal tactics, sub
Yeah.
goals. You say sub goals, but I guess that is a proof tactic. The sub goals are probably in some kind of a proof, correct? Um,
No, they're basically which branch to select at a given time. So you have, so we
See,
have a
that's
bunch of,
also not clear. I'll list my questions, okay? So, what exactly are you selecting, and what those things are? I don't think we'll have enough
so
time here for you to describe, because I have to cover. We'll have to cover four proposals. So I will list my questions, and you could answer to some extent. So four means we have roughly about 20 minutes per proposal. So that is also not clear here. Okay, what is it that the those steps are? Okay, and it seems like that what the neural network is doing is picking some order in which to apply those sub goals. Okay, so it is not clear how applying those sub goals in a certain order will accomplish the synthesis process. Okay, that is not clear.
So while doing synthesis, we have an exponential blow up of possible options we have at each point. So at each point we can do. So if you look at this enumerate at function, so we have a list of symbols that we can choose at this point. So the symbols are have a name and a type, and what our procedure does is it goes through all of them one by one and picks whichever one. He picks each one in turn, and if we eventually get a solution, then it goes with that. Otherwise, it moves on to the next one. So because there's an exponential blow up on this, if you choose the correct symbol, if you choose the incorrect symbol to go on, or if you enumerate the symbols in the wrong order, then you might not end up getting a solution before the timeout, because it's exponential again. So uh,
Yeah, but how do you choose which symbols to choose?
so um, we have the types of all the symbols, I mean the specification that they satisfy
Uh,
and their type, and we know the type of the environment and the type of the goal. So the
yeah,
neural network will
you
guess.
have some function symbols. So are you restricted to choose only among those things, or you can choose outside some symbols? Symbols here presumably denote some operations, right?
Yeah,
Function
yeah, yeah.
thing.
So whatever is in scope.
Outside of the that appear in the specification as well.
So you can choose whatever is in scope and matches the type. So that is already filtered for you. So
Uh,
anything that can plausibly match the type
hmm.
and is in scope. Uh, so uh, yeah.
Well,
So the good part about this is that generating data is easy because at each point in the program, because of this exponential blow up, you know that you can generate the data easily. That there are these 100 symbols available at this point in the program, uh, and this one symbol number 22 was the one that actually led to a solution. So using those, each at each branch you have an exponential, you have uh, you can record the decision that was taken by the solver, and this makes generating data easy. So uh, so what we want
how
to
do you
do is
count the sub goal here? Enumerate at is a sub goal.
enumerate at will take an environment and a type and a goal type and a depth. So, and it'll give you a list of programs uh, of that size
Hmm.
uh, that can be plausibly that might work.
That might
So
work. So some of them may work and some of them may not. Correct.
yeah, yeah,
So that is where the thing is. So it is not just the order. So the way you specified in your proposal was as though the neural network is supposed to just pick the order in which to apply,
yeah.
not
That's what the neural network will do.
okay. But there
So
is
the
a
neural
choice
network will
in
just
12 here. So who decides on those symbols?
so those symbols are defined using type checking. So
Using type.
that
So that is not an input to the neural network. It
no,
is the
no.
order of what? Uh,
So this is right now in an arbitrary order. So whatever. So this is an
so the
arbitrary
order
order,
in
right?
which the symbols are considered, the possible symbols are considered. Am I
Yeah,
right? Huh?
yeah, yeah,
Okay. The possible order in which, I mean, the order in which the possible symbols could be chosen among the ones that fit the constraints. Huh?
yeah,
Need
yeah,
the
yeah.
constraint is not thing. Yeah. So, and then this is repeated, I presume, correct? Uh,
Yeah, this is repeated at each branch. Every time we need to make a decision. this happens. This
So,
this
but
procedure is
based
carried out.
on the order of the thing, some of them might lead to a solution, or some may never lead to a solution.
Yeah.
Okay, but if it terminates with a solution,
Then
it is guaranteed to be correct with respect
it is guaranteed to fit the specification and type check.
to the specification. Okay. So then the neural network would be called repeatedly at each time.
Yeah, at each branch. Yeah, every time we have to make a decision, it will be called and it will be asked to prioritize our list of alternatives. So we'll pick the one with the highest priority that the neural network assigns, and the hope is that this will lead to more solutions.
Yeah, you will call them to do it. So what is it that you will have to optimize here? Okay, so you will be building. So will the neural network will remain the same at each step? You will not modify the neural network as the search goes along, correct?
No, we'll modify it in a training phase before that. Yeah.
No. All this training is. My question was, will you have multiple neural networks?
No, just one, I think.
Just one neural network. Okay,
Yeah.
so that the same thing will be used to get the So your training thing, so data will have to take into account all possible. So there's so many scenarios, right, that you can actually get. I mean, the training data can vary for the same. I mean, in terms of the examples that you choose. Okay.
Yeah.
That is one. And for the same example, by example, I mean a specification and some, the type of the function and so on. So that is one variation. But for that, you can have different symbols and so on, right? So that the different possible symbols are
so that's why we'll encode the environment as a bunch of tokens into the input of the neural network. So the neural network will have access to the environment, the current goal, and the type of the current symbol, and it has to give it a score depending on how likely it is to satisfy the goal.
So this can be fairly big, unless you put some restrict the scope of your synthesis problem, correct? Or it is, you will have these are the kinds of specifications. There's possibly some symbol database that you have and some kind of problems, right? So that is where you will be using some subset of chosen subsets of these whatever synthesis benchmark, okay, that you had links to. And I think those kinds of details you will have to put in the proposal, okay? So what is it that you will, so that it will be clear for you, I mean, as well as, for you as well as us, as to, you have to define your goals, okay? How much, what is the scope of your problem, okay? So that it will also be meaningful for us to evaluate, whether you met those goals and whether the data set that you generated was large enough, okay? For you to do. That kind of, the scoping problem is important. And at least, and I can do. That and Madhukar, I mean, you can join as well. I mean, I just will present all the questions that I had. Okay, and then so that is one. And then how will you generate in your data set the outcome? Okay, so because when you train for each environment which goes with input, you have to somehow know what the most optimal order is. Correct?
Yeah.
So
So
how will you generate the correct output? In this case, what correct output
so
is? Some order, I mean, some
which results in a
order
solution.
which gives you a solution, not only a solution, because some orderings of choice of these symbols to choose, they never lead to a solution, or it can lead after, you know, a long series of steps that for practical purposes might as well mean no solution. Okay? Although there is a solution. So it can be so long. I don't know what the size of the symbols is. So number of steps. Do you need to bound the number of steps that you want to get the solution?
Yeah, so there are some default bounds already.
So these kinds of things. Okay, so your proposal is very sketchy in terms of these things, because this is what determines how I mean, this should be included as part of your scoping. Okay,
Yeah.
and how will you generate the most optimal ordering that it is supposed to get? That you will do by creating some examples of
Yeah.
synthesized code. Is that available as part of?
Yeah, there are a lot of examples available. So we'll essentially instrument it to record all of its options at a particular point and record which one it eventually picked in the successful program, in the successful synthesis, which option at each step it picked at in the successful synthesis, and you will use that as training data for our network. So
Okay,
yeah.
so but it probably is not. So that thing is already organized in a fashion that you can readily use.
No, we have to instrument it ourselves to generate that.
Okay.
So, but yeah, that shouldn't be a problem.
Yeah. So I think adding some of these kinds of things, the scoping details to your proposal is very important, so that because this is somewhat of a, I mean, this problem is unfamiliar. This is not a typical, I mean, although people have, done it, these are not very standard like image recognition or language recognition and those kinds of things, where uh, the goal of the problem is well defined, okay? Clearly defined. So you will have to include enough details in your proposal so we'll be able to evaluate. Okay?
Yeah.
Whether we'll be able to evaluate with respect to the goals you have set. Okay, that whether that has been accomplished or not, which means the goal has to be reasonably interesting and complex, and so that in itself is something that has to be determined. So that is part of the scoping, and how you go about generating this data set, etc. I mean, I know you've provided some link and so on, but the way it is presented now is sketchy, that we'll have to do a lot of work, and you will have to make that easy for us. Okay.
Okay.
That is one comment I had. The other one, I think this was brought up in the last discussion, by Madhukar and Hidar, which is all the rest. We are, we want some verification. I mean, all the rest of the projects involve verification. What is it that you can do? So now I know there is enough work, and that is true for all projects. How you generate the data set, how do you train the training data set, how do you do that the process, that is one part. And the other one is putting efforts towards verification. So it is unclear what it is that you can do here in terms of verification. And I thought that you had been asked to think about that, correct?
Yeah. So one thing we can do is if a sub goal type uh, is the same as the final goal type, then we can verify that the neural network always picks that sub goal. If a sub goal has the same type as the goal, so
Yeah, and Subin, I think
Or if the choice is unique, you mean?
yeah.
But
Or
that's a trivial thing. I mean, if the
no, not
choice,
if the choice is unique. If the sub goal has exactly the same type as the goal, then we can try to verify that it always picks the.
Zubin, can you hear me?
I
why will, uh, or because, but that is not a given that, or the training data, um,
So we are.
will the training data guarantee that? I mean, how will it
So
guarantee?
we are traversing programs in like a depth first kind of manner. So we'll always pick the shortest program first. So the shortest program will be the one that if at any point a sub goal has the same type as the goal, then that sub goal is picked, right? Or if a symbol has the same type as the goal, then we pick the symbol.
Hmm. But can you not verify a more general property that if indeed with a certain bound there is um, uh, a solution with that bound, okay, that you should be able to get it. I
In
guess.
coding, what is it like that in SMT would even encoding the problem would be kind of difficult, I think, because you'll have to encode this language into uh, SMT, right, to describe what is a possible solution. And
No, but that's not clear to me. Okay, in terms of number of, uh, so because you're repeatedly invoking, this is a thing. You have to repeatedly invoke this network, and the number of time, the bound, etc., will be depend on the number of times you'll be invoking this network. Correct.
yeah,
So you won't be able to specify that. Uh,
Zubin, I think last time we discussed one or two properties that you may satisfy, like verify for changing the type of the thing. Like, did you consider that, and what do you find?
I mean, changing the type of. I mean, this is one property that you could verify, but I don't know. Will Sahil, do you have any comments on
No,
what
but
kind of?
why do you say this bound will not be able to, you will not be able to express in SMT? No, I would also like to hear what was discussed and the thing. So that is you will have to populate, you will have to refine your proposal to propose in that some properties that we can actually look at and then verify. Right now, I'm not sure if your proposal has anything about that. Now, getting back to what I had proposed, why can't you do it? Because your network will be computing a function, okay? Whatever network after the training, you're verifying the network that you get after the training. And since you said you'll be using the same network repeatedly, so the bound is if indeed you're able to, there is a solution with a certain number of in sub goals that you have. If your network was picking the perfect candidate at each step, then you should be able to get with n invocations of your network decision. Correct?
Yeah, but how will we how will we express in Z3 that the network generates a program that is well typed and satisfies the predicates and so on. So for that, we'll have to encode the entire language that we're synthesizing into Z3.
I'm not asking you to verify that. The thing is, if indeed it has proposed some solutions, uh, so it has only proposed solutions. You don't know what at the end of that, if you of those choices, what you get is actually a synthesized program that meets the specification or not. Okay. So because that is, I mean, this network can propose certain decisions, and what you get is not any. Okay, so anyway, so these are, yeah, Hitat's suggestion is good. So I think this is what will happen. So when I get into some proposal, I keep on talking about that. So at the high level, these are the things, and I think once you furnish this information, we may have to set up, whatever suggestions that we're making right now, you'll have to do within the next class or so, the next class. And after that, depending upon the severity of the thing, I mean, how well that we have, we may have some individual discussions with you for which you should be willing to be available. Okay. So I don't think we can discuss all the things, and I think that suggestion is good. So I get carried away. So I have to stop here, and then I'll give Madhukar and Hitat some, to list your questions with respect to the thing. And I think those questions you will have to, I mean, you can decide to send those questions in writing later on as well, or you can propose these things, and you will have to address them. Okay? That's the thing. So,
okay, so I just need 1 minute. So I mean, so when I asked you something, I didn't get your answer. So I was asking you that we discussed one or two properties that you may verify, but did you consider them? I don't find them written in your proposal. So what happened with those?
I mean, we changed our proposal a bit since then. So we're looking at a different system now and a different kind of.
Okay. So here you cannot even have similar, like there's no room for similar verification properties, right?
I mean, what kind of properties were you suggesting?
Like last time, as far as I remember, you said that okay, we have some types and we want to synthesize something, and the idea was that if you change the type to something else, then maybe it will output the same thing or not. Maybe, I mean, some similar sort of simple stuff, not very hard, but I mean, I was thinking you should think about some property that you can verify for the network, because I mean, the way you are doing this proposal, of course, it's very interesting, and I won't even pretend that I understand everything that's going on. But you are doing DL for SMT, but I mean, you are using the this network to do something, right? Synthesize a program, but you're not doing the other way. You're not trying to verify the network using SMT. So you have to think along that direction too.
Yeah, but I think that'll only be clear once we have a working network.
Yeah, one more quick question, just about the example that you showed. So for the AVL example that you showed, so the balance condition is already in the definition of AVL, right? That it has to be always balanced, correct?
Let me check once more. Yeah, it is. There is a balance condition, but it's not a precise condition. It's the
Because
height of.
the height thing that you say, the height should be +1. I mean, that alone won't work, right? Because you can always keep on just appending that to the left thing, and that won't be a AVL tree.
What are you saying? Sorry.
I mean, you said that whenever we insert a node, it had the height should be at most, the change in height should be at most 1, correct? That's the condition.
It is not that. It whenever we insert, the height has to be less than equal to, greater than equal to the input, and less than equal to the input +1. That is the condition that we had.
Yeah, so the difference is at most 1, correct? Like that's how it translates to. That's what I'm saying. Yeah. So I mean, that alone won't be sufficient for AVL tree, because you need the balance condition. So
the balance condition is in the definition
of AVL. Okay.
Yeah.
Yeah. Regarding the network, so I mean, how you're encoding all this? Like whenever you give what input you give, like what's the procedure in which you are encoding your like input and output?
So the output will be a number between 0 and 1, which will be
Okay.
the score of the sub goal,
Mhm.
and for the sub goals and the sub goal and the environment, we'll just encode the list of tokens. So we'll encode. So if this is the type of the goal, we'll just encode the tokens in this as the.
Yeah. So this is important. This is part of what your specification is, because I mean, there's nothing in the proposal. You have to add at least one or two examples, Zubin and Sahil, to be able to understand what's going on. Okay. There is no example at all. I mean, saying what the symbol is, what does it mean to choose. There's absolutely nothing. Okay, and you'll have to make those things a bit more clear. Okay, so unless you do that, what exactly is the data set, etc., we don't understand. Unless you want us to go read the paper, okay, maybe those papers are there, but at least you should say, oh, it is specified in the paper, okay, and to make our life easier, you should at least, at the minimum, put a few examples. So without that, the only thing we can understand is, oh, this network, you're designing some neural network to assist in synthesis. Pretty much, that's all there is in the proposal. Because otherwise, we'll have lots of questions. Okay, and I think this is, what I think Hitat is also saying. Okay,
so I think once they start to create this network, maybe it will get clear for them to come up with examples. So I mean, it's possible that at this point they don't even actually have the full understanding of it.
I mean, they have these data sets, etc. It's just including it as part of a proposal so that the reader of the proposal will get some a clue as to what the inputs are. That's all I'm asking, because anytime you ask the question, Zubin is showing a whole lot of information, with all these, things and so on. He knows what the symbols are and what he means by symbols and what the sub-goals are and so on. It's just that it is not presented in there, okay? So there is some work to be done here, okay, to communicate that. Maybe that's all clear to you, to the two of you, but certainly not to the reader of the reader. Okay. In that sense, it is hard to evaluate a proposal. Okay, that needs to be fixed. Okay, so any other question? So I think we need to move on. Okay, and we may have to. I mean, yeah.
I think we can have another meeting with.
I think we'll do separately. So the next person to go is Diganta and Saugata. Okay, I'm just going in the order in which I had most questions about. So please, I'm going to give them. Yeah, so you guys can go ahead.
Yeah. Okay. So I actually had sent the document, the proposal document quite a bit back, but like after seeing some of the other people's proposals, I think.
Yeah, but please share your latest one.
Yeah, I'll share basically the same version of the document, but with some more things in it. Just give me one second. So is my screen visible?
Hitat, you go ahead with your questions in Madhukar. So I will this time, huh? And I'll have my questions.
So is the
It is
this
visible.
document visible? Hello.
Yeah, it is visible. Please go
Oh,
ahead.
okay. Yeah. So as I've okay, so basically I'll explain what the basic problem, what the goal of the problem, the project is. That in a wide variety of different like deep neural networks, we have certain situations where there are sometimes a lot of symmetry within the inputs of the network. Specifically, what I mean by that is symmetry between the inputs in terms of permutations of the inputs. So what we wanted to do in this project is to look at the cyclic subgroups of the entire permutation groups of the inputs, and for those subgroups, develop some method to, in general, verify any such invariance under the permutation of the input for any given network. So if I formally state this property, I think what I'm talking about will become very clear. So suppose we have a neural network N, and well, we denote its output on inputs x1 to xn by this. So all the permutations of this input will form a symmetric group of n items. Let's call that Sn. So if we're given some subgroup G of Sn, and we might be interested in, like, it is very common for such a property to be meaningful, where for any sigma belong to Sn, for any sigma belong to G, n of x1 to xn should be the same of n of sigma x1 to xn. So, for example, if you think about say the tic-tac-toe example, right? So there we encoded the entire neural network in terms of the board in terms of some zeros and ones, and the move also in terms of zeros and ones depicting where the next player is playing the move. So if you were to rotate,
I understand your proposal fairly clearly. Okay, so that's why I think what we should do is, yeah. So I don't think there is need for representing. So Hitat, that's why I asked you to ask questions. If there are any questions.
Oh, okay, sure, yeah.
Yeah, so I don't think we need to. I mean, you have done with your examples and so on. So
Yeah.
the only one question, I mean, maybe I'll go ahead. Okay, with respect to, so as I said, these questions will be with respect to understanding what the problem is, and that is clear. Okay, so one question I had was the sigma that you considered.
Right.
I mean, it is defined as, okay, so it should be such that any neural network should be, of course, what exactly is a sigma, it depends on the actual nature of your inputs, correct?
Right, yeah.
So that is the thing. But any sigma under which you expect the n to be, classification preserving is what
Right.
you call it. Okay, that part I understand. So you will be defining sigma for different things. Now, I don't understand this n. Okay, this n is after some number of sigma application, the data you will get back to what it was.
Right. So in this particular document, I have it as k. So
okay, fine. Yeah. So all that I understood. Okay. So the question we had last time was that you would have two parts. One is your verification will be for an arbitrary. You will have a framework that you will design. So for an arbitrary neural network, how you will verify this using Z3.
Right.
Then you will show its utility in applying it to specific neural network. Okay.
Yes.
And the examples you have seen. Okay, you have listed. So the question is, will you be doing that for all those three things that you have seen, that you have proposed, and you will be designing some sigmas that are reasonable for each of them, correct? So that is your
yeah. So I mean, that is my plan. I hope that it won't be very too much of a work to do it for three things. See, at least at the very least, I think it should be doable for two things. The tic-tac-toe example is already quite a bit, like, we have done it in the assignment. This is the verification that we'll need to do. And the period finder, we have already done some work towards that, so we can continue that, I think. Yeah.
Nikanda, this is not a proposal that is submitted on Moodle, right? Like
Yeah.
had
So this is just I have just basically described the examples in more details over here, and just
I think you should upload it as and when you refine it. This comment applies to everybody. Okay, I expect this thing to be a moving, an evolving document, and please, it'll make our life also easier to validate and so on. So as you refine it, as you upgrade, as you develop your project, you should.
Nikanda, can you just scroll down to the bottom, like just go through it very quickly? Just show me. I mean, I'm just seeing it.
Yeah, okay. I'll just go over the various parts of the document. So here I just describe the property and it's stated in some mathematical symbols and all that. Here I say what basically says with that we'll develop the general method and then show it in some examples. Over here, I just describe the examples in detail. The tic-tac-toe example is just the assignment examples, and I describe which property they want to check, which is basically rotating the board by multiples of 90 degrees. So that will correspond to some permutations, and I'll be able to get a sigma for that, and then I'll apply my method for that and verify that.
Yeah. So Sahil and Zubin, I mean, this is you kind of seeing through the thing. This is the level of detail that you will have to furnish. Update your document with, so that we can actually not only validate, we can also make some constructive comments and suggestions about the thing. So this the thing. So what is it your input will be like and so on. So so please take note. Yeah, go ahead. We can talk.
Yeah. Okay. So the rest of the documents just talks about the other two examples that I had previously mentioned briefly. So this Cinderella example refers to the Cinderella and the Wicked Stepmother game. I have basically worked out by hand a few runs of this game, and I've decided for a bucket size of 2 liters. This can be parameterized. In fact, I mean, I can just keep it some B, but it seems like 2 liters leads to games that can either end quickly or long, run very long, depending upon what kind of moves are being played. So yeah, over here, what we'll do is basically we'll develop a move classifier similar to the tic-tac-toe example, where given a particular configuration of the buckets and given the fact that Cinderella is emptying these 2 buckets, the neural network will tell whether that's a good move or a bad move. And the way we want to train the neural network to do that is we'll basically, by brute force, check whether that particular move lets Cinderella somehow continue playing for at least 2 rounds. If that is the case, then it's a good move. If not, then it's a bad move. And we generate some data set based on that. And we use that to train our network, and the network will give us a good move or a bad move prediction. Now, over here, what we want to do is, again, we want to check basically the invariance of this network under the permutation. And we want to do that by rotating the buckets because they are arranged in a pentagon. Just rotating the buckets by 1/5 of 360 degrees should not change anything. Of course, we'll have to correspondingly rotate the move. And that will correspond to some cyclic permutation of the inputs. So the final example is the period finder. And so I attended, in last class, the other groups have talked about a frequency counter example. And I want to emphasize that this period finder the neural network is not achieving the exact same thing as the frequency counter. So I have actually, Shogata will very briefly show the data generation code for this particular example, and then the things will be clear. So see, in the frequency counter thing, we had, which is what I'm saying in this note, the problem statement was that there was some frequency, like some sine wave or something like that, and then there was some noise added on top of that, and you wanted to recover the frequency of the sine wave from the noise signal. Here, the network assumes that the signal is periodic. That is, there is no noise per se, that it's perfectly periodic. But the waveform itself can be anything. So it can be any arbitrary waveform, but it repeats perfectly. And we want to recover the period of the signal. So this is why I'm saying, calling it the period finder, and I'm defining the period very clearly over here. And so that is what we're trying to do over here. So here we'll use the same sort of a setup as the other frequency counter project has used, in terms of like we'll specify some number of samples, and the signal will be specified as an array of samples. And we'll basically verify the phase invariance of this network with respect to the phase shifting of the input. So phase shifting of the input over here, since we're assuming the phase signal to be periodic, will correspond to acyclic permutations of the inputs, and they can use our framework to
Here,
verify whether that's
I
the
have a
case.
comment, a general comment. You remember that I know that you're using all the invariance properties as your main thing. And of course, for each of these examples that you've chosen, that there is also independent correctness properties and robustness properties that you can
Right. Definitely.
now, no. Okay, so that you can also try. But more importantly, you remember that that talk by the PhD presentation that you attended, that
Yeah.
as well. So there, one interesting thing that came about was he was actually doing training for this particular problem using only these rotational data, okay, and then getting it trained on the thing, and then regular data, okay, regular data set, and he was comparing the two things. That's how I understood. Okay.
Right.
So if you had the training based on just regular, and then data that also gave it, on a rotational basis, I thought the accuracy that he could get was he was comparing. Okay?
Right.
I was wondering if you were going to do that anyway. If you could generate data, one set of data.
So are you suggesting that, say, for instance, for this Cinderella example, if we talk about that, that like basically I train two different networks, suppose, one on just the direct data and one on the data augmented with various rotations, and then compare the accuracy. Is that sort of what you're?
Yeah, I'm what I'm saying is, get a network in which you that data will be just standard regular data. Then you will also train it by presenting these rotated data. Okay.
Right.
Then you see what the difference is.
Right.
That's what.
And I mean, so as far as I remember, over there they were comparing those two networks by basically just trying out various different adversarial attacks and then seeing how often it failed, right? So over
correct.
here, I mean, I can do something similar to that, but I don't know how to, say, for instance, use the Z or the verification engine to compare the two networks, because it might very well happen that the verification engine just generates counterexamples for both the networks, right?
It can be, but
right. But yeah, I can definitely try doing that as well. So for each of these examples, I can
maybe it fails less often when you do if you also trained it with invariance preservation data.
Yeah, but then over here, like, we are not checking the network whether it fails on a particular counterexample or not, right? So we just like if we basically try and take the two networks and verify them, however many times we try the verification, we'll end up with the same counterexample unless we assert it out or something like that. So
but what if the accuracy itself is better when you train it?
Yeah, that is definitely true. Yeah, that can definitely happen. Yeah.
Also, I will suggest you to put some numbers in this period finder. Like, don't keep just variables k and everything. Like, just put some numbers that what is the size that you are considering.
Right.
The number of samples.
I wanted to do that at a slightly later stage after I've sort of experimented a little bit with what is feasible in terms of time limits for verification. But
you can see Somodev's and Diksha's proposal. I think they though your thing is different, but I mean you can choose the same parameters maybe. Like it won't matter.
Okay, maybe I'll try those same parameters as they
and do update this. I don't understand your Cinderella wicked step mother example exactly. So I will try to read it and then maybe we can discuss it later after this, maybe tomorrow.
Okay.
Yeah. Okay.
Okay. So, any other questions, Madhukar?
Yes. So
So you said Shogata was.
he'll present some of the we basically just written some code to generate data for the period finder. We thought that
Yeah, I would like to see that, because see, since we are spending. So here's my plan, Mithat and Madhukar. I know that we won't be able to finish. Okay, we have two more. Okay, we had already done two last week. Okay, so we can, for those two teams, we could give feedback. Hithat, you were not there, but then we can give feedback later on. But I want to listen to the other two. Okay, so which means that we'll have to stay longer beyond the class. Okay, so I want to make sure what Hitarth's and Madhukar's time constraints are. Okay, so I'd like both of them to be here, which means even assuming half an hour, we'll have to be willing to stay here till 5:30. I'm not going to insist that everybody in the class has to stay. Okay, that is, it's up to them. So I was wondering if we could continue here till at most by 5:30. Okay, till 5:30.
So I think I can stay till 5:15.
5:50. Okay, so let's plan on like that. Okay, so 15 minutes. You have 5 minutes, and then the rest of the other two people will have 20 minutes each. Okay, so that will bring to 15 minutes.
Hello, sir.
5:15. Okay.
Hello.
Yes.
Yeah. So what we are doing is basically taking three different waveforms. One is sine and sawtooth and square. So then this sum to x function, so which takes basically a number x and it partitions that x into n numbers, which are basically random numbers. Okay. So then we have some other functions like so this is a function which computes given any number, it's all prime factors and its powers. Okay. So next is this function. It is the reverse of LCM basically. So if you give input to this function a number, it will generate three numbers whose LCM can be equal to that input. Okay. So for example, if we run this,
Can you just give a broad overview of what you're trying to achieve here? Like what?
yeah, so basically what we are doing that we are taking three different waveforms and they are linear combination. Okay.
Yeah.
So
Okay, so you're just like multiplying them with some number and adding it up, right?
adding it up, and those numbers are randomly generated.
Okay, cool.
This you're going to be using to do the rotation and so on, is it?
No, it's just creating the data set.
Okay.
Yeah. So
it's superposition. So you can maybe leave the details. We just
okay. So basically, if I then should I run everything and show the final output?
Yeah, I don't think we need to see your detailed code and so on. You should give an overview of what you have done up to now, if that's what your intention is. Okay, that this is for generating the input data, I presume, correct?
Yeah.
For the period finder, right?
Yeah, for the period finder. So given a particular number of particular amount of period, we are generating 1,000 samples, and basically.
And the period is always the LCM of the period signal.
Yeah. So,
all right, cool. I think we got to this point, but you have not worked on the network yet, right?
No. So this is the data set, actually, final data set.
What is the sample like size that you have? How many points are you
So if I have 1,000 samples and if I need 5 data points, then here is the nested list. And
This takes quite a while to run, so we haven't actually generated
so
any
at the
large
end,
amount of data
there is
set,
a
but the code
plot.
Sorry.
Let me show you that plot.
Yeah. So what I would do, one suggestion I have for the both of you, okay? So try to do, you can spend so much time in each
Yeah.
part of your task because your project is kind of, there's an end-to-end goal as well, okay? So you should, for example, for each of these application or the kind of application that you'll be testing your invariance methodology on, first you should specify what the sigma that you will be using will be, okay? That is something that you can actually update your document with. Then what I would say is choose some small example in each, a small version of that, each of those two things. I know, I mean, in this case, maybe you can choose that. And then push that through end to end, okay? Put a smaller version of that. I mean, that's just a suggestion. Since you brought up the thing, it is taking too much time, even in generating the data set.
Yeah, so this is the data set basically.
Okay, Shogoto, what is the
Yeah,
time?
I do agree with sir here that we probably need to do that for a smaller, maybe a ill-trained network at first, at least.
Yeah. Go ahead.
What is the time for this, like 1,000 samples per what time? Microsecond or what?
There is no time associated with this at this moment.
How are you going to find the period? So the period is the number of
It's
steps.
yeah, total number of.
Okay, so you're not spending time with it. All right.
Sir, may I ask a question?
Yeah, go ahead.
So in the what will be the output of your neural network that will tell you what the period is?
Oh, you're always welcome to ask questions, guys. So we're not the only. Yeah, surely, yes. Go ahead. Yeah.
Yeah, so you will train a neural network, right? There will be some output of that neural network. From that output, how you will find the period of that function?
No, so the output
Yeah, so
will
period is already given actually. So
yeah, like the
because the
output
network
node,
is not already designed. So we are just labeling the data set. So
Shubhato, he's asking that your network will output what? Like it will output the step, right? It will be one neuron which will output the number.
It will output the period, right?
The period number itself, as a number, it will output that.
As a float or integer?
Well, I mean, since neural networks are always working on floats, it will be floats, but we'll just round it off to the nearest integer.
Basically. Okay.
So while calculating the loss, you have to make sure that whether you
We'll definitely need to put that in there. Yes.
Okay, cool. I think we can go ahead with the other one. This is fine.
Yeah. Okay. So I'll just take 2 minutes to just point out something here. So if I wanted to basically show some of these plots here, so one of the things that I wanted to point out was that this is each of the things, like for this particular example at the very least, that each of the things here, the period that we're finding is not the primary frequency or anything like that. So this will be totally different from the other example. I just wanted to make that. Yeah, sorry.
Yeah. Okay. So yeah. So next, shall we move on? If
yeah, I think we should.
Yeah. So Rishikesh and Anantu. I'll have to give them. Yeah, you guys can share.
Hello.
Yeah, you're audible.
So basically, what we were trying to do was we will give the input as some shapes or some really basic characters and try to understand what it is. So we have just we didn't actually go, like we have just started doing it. So we just managed to create some small data set.
Hello.
Hear you.
Yeah. Um, so can we give like a real update on Monday, because uh, we haven't really done much of the. I mean, we haven't really started the code itself, and plan on like doing it in like the following days.
Yeah. So one thing that I suggest is you will have to see some progress. Okay. So one thing that you can actually start thinking simultaneously is if how you would express once you decide what your inputs and outputs are. Decide you can try and formulate those properties in Z3, because see, you don't need to wait until late in the game to do that. Okay? You can start thinking about, since you've already given some English description of the properties that you want to verify, now you should be at least at the stage you know exactly what your inputs are, okay, or what your outputs
Right.
are.
Right. So
In terms
for
of
the
that, you can start specifying the Z3 formalization of those properties, okay? And I mean, you can even start verifying it for some, you can make your own functions and then you can start verifying so that you will know at least what those things are. At least you know, that much progress if you make. And then you can add those things to your proposal is what I would do. Okay. So yeah, so what you have is, yes, you will have to show some progress, okay?
Yeah, one more thing I wanted to add to it was that in your proposal, I mean, the first important thing is that you have to mention what size of images that you are using, and even
yeah, we're planning to do like 15 by 15 pixels. I mean,
okay, so
that should be enough, right?
like these things have to be included in the proposal itself. That what is the size of the images, how are you going to get the data set, and everything. Along with that, the properties
Yeah,
that
about okay.
the third property specifically, it doesn't actually make too much sense to me, because you said that you will check what coloring, that whether the coloring changes or not. I mean, I'm
Well,
assuming that you will pre-process the image and convert it into grayscales. Then what's the purpose of checking for like changing the coloring? Like,
No, but that's a different proposal.
That's my
yeah,
question.
Yeah, Rishikesh and Ananto working on this language thing.
yeah, in the third property they have mentioned this thing. Like, can you open it up?
Coloring, is it? What does coloring mean in this context? I don't understand.
right. Well, I guess we didn't really think about that per se, but
Okay.
so like since we were thinking about languages, it was just kind of like if you scan a picture in, then the color doesn't matter. So like from a neural network standpoint, it doesn't really matter, I guess, because we can just convert it to grayscale, then work with that.
Yeah, so I'm just suggesting that you should write at least 5 or 6 properties and try to make them, useful properties, something which makes sense. Okay.
Okay.
Cool. So who is left now? Like, are we done?
Me.
No, there's one more. I think
Okay.
is it Kapil? No, Argadi.
Yeah.
Yes.
Can you hear me?
Yeah.
Hello. Hello. Can you hear me?
Yes.
Yes.
I
Yes.
Okay.
co-host. And Shayak is not here, correct?
One second.
Argadeep, I've made you co-host.
Yeah, I'm sharing my screen now. Can you see my screen?
I can see, but I asked, yeah, Shayak is not here, correct?
Yeah.
Okay.
So this project proposal is the one we submitted. This is a little bit outdated. from what we have progressed, but the core idea is still the same. So what we are using is, I have gathered about 1500 of these kind of 16x16 images right here. 1500 of these, and what we are doing is, the goal of this network is to take as input a grayscale version of these images and then try to reproduce the color based on what the network has seen so far. So, and we were also, in addition to this, we were trying to have uh, some sort of invariance
No, no. When
under
you say
rotation and mirror.
reproduce,
Yes.
reproduce, will you also give the color of the original color?
No. We are not. We're just gonna give the grayscale image. There will be no mention of the color.
Yeah. So
So,
then,
for example, there's no guarantee that the color will be reproduced as it was in the original image. It's just that it'll be some valid coloring, hopefully.
yeah, but how do you define that valid coloring? That is one question that I
Yeah. So
had.
what we are gonna do is, we actually, this is actually, we decided that we're not gonna have a valid coloring. In fact, we're gonna try to. I mean, I don't think there is any notion of valid coloring, since we are.
No, see, but you could have what I was thinking. See, even in it has to choose some different coloring. If it just makes everything black, it has to
Yeah. It will.
coloring
Yeah.
to distinguish the shape. Huh?
Yes,
So
so one way we can do that. So right now, the images that I've gathered, there are many different kinds of images. Like there are fruits, like all these kind of images. So the problem here is that, suppose there is the a network detects, say, this slanted line kind of thing. So there might be many different images with this slanted line, and in those different images, the slanted line may be colored differently. So in that sense, the network will kind of get confused about what that slanted line's color should be, right?
Argodeep, I think there's, I mean, maybe you don't need to worry about that exactly, because slanted line along with this bow shape thing.
No. Yeah. I know, but like in simpler images, this is just like a vague example.
I think the main thing that you must make sure while you are training the network is that that there is no such exactly the same shape which is colored differently. That is something which you need to avoid in your data set, because there are sprites that you like find that
Yeah. There are sprites like
they
that
can
as
have the
well.
different color for the same shape. That is something
Yeah.
which you must avoid.
Yeah, this is kind of what I thought about. So what I thought was, first I'll try to train the network on this completely general data set, and then I thought I'd gather a sort of homogenized data set which contains, say, a certain type of things, like it contains, say, only fruits and vegetables, where each fruit and vegetable is in different shape. In that case, we are hopefully likely to find different patterns on each of these images, and it'll color them according to the way it was colored in the data set. Right. In that case, we can define some form of validity. So right now, the data set we have is not like that. So, but still, we are getting like a decent result, because I have made the network. I'll show you just now. So essentially, the goal is to convert this into grayscale, put this into the network. The network is a CNN, and it'll try to guess the coloring, and it'll output the coloring. So the change we had from the initial idea is that, in the initial idea, we were using RGB value for coloring. So RGB value, is red, green, and blue color arrays. This is like, since we are using 16 cross 16 images, RGB value will be 16 cross 16 times 3. So one improvement that we can use is, instead of using RGB, we can use LAB format. So what LAB does is, in LAB format, L is the grayscale image itself, A is blue and L is a red and yellow color, and B is the blue and yellow, and red is the green and red. I'll show you this as an example. Uh, so this is the L channel, this is the A channel, and this is the B channel.
Okay.
Right. So what we're gonna do is, we're gonna use this L channel as our input, right? Since this is the grayscale image itself, and what we're gonna have to do is, we are gonna only predict A and B channels. We don't have to bother with the L channel, and we are gonna combine the input and the A and B channels that we predicted, and we'll obtain the coloring. In that case, the benefits is, we'll only have to deal with two layers of 16 cross 16 arrays. and the coloring will maintain this black and white structure. So it'll not. So I actually made colorings with both RGB and lab, and I noticed that the colorings which we obtained from using RGB values was a little bit was a lot more hazier, because the grayscale structure itself is not being maintained either. So right now, I'll show you the network that we have. So this is the example. So we collected like a bunch of images, like 15, 1600. And then for each image, we rotated it and mirrored it to obtain 8 different images. In total, we got 15,000 images for our training data. Now, this part is kind of outdated, because I've noticed that accuracy with respect to the, I mean, this is what we were talking about earlier, basically. So here's the network that I have. One second. So the network, and I'll show you like an examples of what I have printed. Here, this is using the LAB format. So for example, this is the black and white image that we had, and this is the coloring of the image that we obtained. And even more examples
And
are.
what's the original one? What was the
Original one? One second, I'll have to search for it. Original one was a little bit redder. One second.
That's beautiful. That's
Yeah,
really...
this one.
Okay, cool. That's very interesting.
And then I'll show you more. One second. This is some pixel art, and here is the coloring. The original one was pink, but actually I think the data set had this kind of image with a lot of different colors, so I decided to go blue for this one.
So this one is with RGB, right?
No, this is with LAB. This is I'll show you the same image which we colored with RGB as well. So this is as you can see, if you notice that the grayscale background is being maintained, like the structure of the image is the same as it, like the grayscale image. If you convert it into grayscale, it'll stay the same. But I'll show you now RGB images. So this is the same pixel art that I used to get this coloring for with the LAB one, and now this is the coloring of it using RGB.
Can you show them side by side?
Yes, one second.
Yeah, there's a lot more here.
Yes, this is a lot hazier because the black and white structure itself is lost.
Yeah.
And there are a few more as well. There is a book, this one. This is the black and white, and there's the coloring.
I think that's pretty cool, and I think maybe you can. Okay, let's move on from the examples. That's very good, but
So one comment I had, I mean, of course, not on this, on the verification part.
Yes,
so
yes.
You should be able to verify. I know that you are trying to verify that if you rotate the color.
No, that is just one thing that we're trying to verify.
Yeah, but more important than invariance under rotation would be that somehow trying to define what a meaning
yes, exactly.
is. That in the sense, at least it shouldn't lose certain boundary.
Yes. That's actually what we're also doing. So testing invariance is one thing. So another thing that we planned is, as I know mentioned in the paper. So this is just an example. This is not exactly what we're going to do. So suppose we define what a sword could be like, or for say any object. So here, for example, what we've done is we have blackened out everything other than this cutout. So what we can do here is that then we can verify some other properties, like we can verify whether there is some input for this free space here such that the output is colored green. Or we can also use the invariance, like whether there is some input for this part here such that if we rotate this image, then the coloring is different.
What do you mean by input for this part? What exactly?
Input as in, so what we're doing is these are all Z3 variables, each pixel, right?
Yeah.
So we are fixing these black parts and these white parts are free.
Okay, so you're going to put grayscale thing on that, like some kind of noise.
No. We're not going to put anything. We're going to let Z3 put.
I mean, the Z3 will put something and try to find
yes, a grayscale image that it is colored green, says, for example.
Yeah, that makes sense.
Also, this is another like an inverse of this, where we in fact force an image on the foreground, and then we are trying to find a background with certain properties. Say, for example, there is a sky on top and a grass in the bottom. This is a twig tree kind of thing, but we can find better pictures hopefully. So probably like something like this will the grayscale version of this. I don't know, maybe smaller.
Advedi, what are you trying to do here? Like, can you
Huh?
like you don't need the image. It's okay. We can assume that there is one.
Yeah, anything. I mean, yeah. So this is what I have. So I think we can do for verification. Is that like alright? Or
So,
Okay, so
without rotation, what would you verify?
uh-huh.
Without rotation, what is
Yeah.
the kind of property that you would verify?
So we can verify that the output might be of a certain color. Or that yeah, like the output may have, say, there might be some structure inside the output. I mean, on the output, which is
Yeah, I mean, see, the kind of thing that I thought that you could do. So, what can you specify in terms of when it is colored as grayscale? There
yeah.
is certain distinctions in the boundary where it is making. I don't know if you can capture those things. Okay, you would want even after coloring
Yeah.
that distinction to be maintained. Okay,
No, that is actually, I think, automatically being maintained because of LAB format.
Is it? No. But that is the intention. But your coloring might violate those things. That could be a kind of correctness property. Or maybe it is.
No, if we
so
take the
accurate.
colored image and then we convert it back to grayscale, it will be the exact same image as the input.
Well, how do you?
That is because in LAB format, the L channel is the grayscale image.
I know that.
Maybe we can do it if we use the RGB network, which I also have here.
No, I'm talking about Z3 verification. Okay, I know that you're already doing it while you're testing it. Okay, I'm not talking about the testing part. Okay?
No. Okay. So what do you? I mean, grayscale boundaries.
Is your network so perfect that it never violates after?
No, it's not actually a property of the network. It's because.
Okay, so Professor, what he's doing is that he's maintaining the grayscale image and he's putting the color over it. So when you remove the color, you get back the same grayscale image because he's not reconstructing the image from scratch. He's keeping the whole grayscale.
Yes.
No. I still don't understand. So let's see. So go back to your two color pictures.
This one.
No.
Wait. Examples.
Input, output. Yes, example.
Okay.
Yeah. Okay. So.
Okay, I think I see what you're doing.
No. So this is the input. This is the output. Correct?
Yeah.
Let's suppose now. Suppose here this whole thing is white. Okay. But whereas here, this whole thing, the one that I don't know. You can't see my cursor. Okay. There is one bottom here where.
Oh yeah. I see.
Yeah, but whereas here it is not in the same color. Now.
Yeah.
Now, part of it is in some color, part of it is different color.
Okay, I get it now.
Is that a correct coloring? I know.
No. Yes. I know it.
I'm getting an idea. Oh, okay. That is the boundary. Okay, but it is not exactly. Here it's
yes. I see. I get what you mean.
Different colors. Is that correct? Or is
yes. Yes, you're right. So this part is also being colored brown, which is not a boundary that is present here, right?
That's what I meant by boundary preserving. Of course, if you convert it back into grayscale,
Yeah.
I don't know. I mean, even if you convert back into grayscale, I'm not even sure why this would, if it is inaccurately colored brown here, it may, when you convert it back, it may put some grayish tinge on that, which will not be exactly white. So there is a discrepancy here.
And this is probably like some grayish tint as well. Like this is probably the same shade of white that is the shade of brown. But I don't know. I mean, it should not do it because it's. Yeah, but I get what you mean about the brown part. Yeah, I think that might also be a good.
The thing is, how do you specify this in your input is something. Yeah, I mean, you can actually specify. Okay, in the sense, anything that is pure white. I mean, if two things are in different color here, it has to be in different color. I mean, different shade in your grayscale picture. It cannot be colored differently or something like that. Okay, or up to a certain discrepancy in color. Okay, so if you could define, orange versus reddish, okay, somehow they're being the same, you allow up to a certain tolerance for them to be colored or something like that. Okay,
Actually, that is a good. I think I'll think about how to implement.
Yeah, I have one more suggestion that you can verify how much cropping can you do. Like what you can do is you can remove
but
the boundary
this is
and make it black.
Huh?
From the image, you can remove some of the boundary and make it black, and then
Okay.
check whether the coloring is within a threshold.
Okay.
How much tiny cropping can you do? Like this is one of the property that you can verify.
Yes. Yeah, that's also a good property. Yeah, I'll think about these. Add these to the document that I have. So, do we have to submit this document again?
If you have updated it, then do it.
Okay.
Just update it on the page.
I think it makes sense. Okay, so I see everything doesn't have to be. I mean, if you ask me that question, yes, I would say yes. I mean, if you're saying if there's a formal requirement, if you're updating it anyway.
Yeah, I'll update. I will update it.
Okay.
Yes.
Why should it be considered as some kind of an imposition? Yeah.
So is this fine?
Yeah, I think I certainly want to see, as I stated when the rest of the gang was there in the class, to update the property section in a formal way. Okay, in a formal way, so that you will list all the properties formally. Okay, that I know you will eventually submitting it, but having it as part of it. Yours is fairly detailed enough that we get, except for the property section.
Yeah, I think it was really good. I mean, it was good.
Okay, so Rishikesh and Anantu, I mean, we'll have to.
Do I stop share? How do I stop
Can I
share?
just ask, like, out of curiosity, how big is the network that you're used?
Yeah, sure. So this is the network. So what we are doing is kind of this is the 16x16 input, and then it goes like 8 layers, 8, then 16, 16, 32, 32, 32, 16, and then 2. This is like this is the width of the layers. I'll show you the summary if you want, but then I have to execute this again. 1 second. This is the network. It's kind of big. I think there might be like probably need to fix it, some of it for the Z3 stuff. But
yeah, but then it's like the number of like neurons in each layers is not.
Yeah, that's true. I mean, it's just the feed forward
of it.
Yes.
Yeah, that is what I was wondering, like whether it's deep or wide.
It's kind of big. I think there might be like probably need to fix it, some of it for the Z3 stuff.
What is the accuracy that you have got in this? What's the accuracy?
Oh, I haven't tested accuracy because I didn't know how exactly. I mean, initially in the plan, I suggested that we could use a distance matrix.
Yeah, just use normal mean square error. Like, why not use that?
Oh no, you mean loss? Loss.
By a loss, you can always calculate.
Yeah, this is the loss that I got. But accuracy is not really like, because since it's the output is not like. I haven't tested accuracy because I didn't know how exactly. I mean, initially in the plan, I suggested that we could use a distance matrix.
So what you can do is like you can calculate the mean square loss and see if it is inside a range. Let's say.
Oh, this is the mean square loss actually. I mean, TensorFlow does this. Can you see?
Yeah, I know. I'm saying that for each output.
Oh, okay. I see. Yeah.
I think there is echo.
Yeah, there is.
All right. I think if you get my point, that's what I'm saying. That
yeah, I get it now.
Output, just check whether the mean square error between the actual coloring and your coloring is, that's smaller than some threshold, and then just find if it is, then say it's good. Otherwise, it's bad, and then find how many are good. Okay.
Okay. All right.
Okay. I think if you get my point, that's what I'm saying. That
yes, I got your point.
Yeah, it's an echo, so you need to stop sharing.
Yeah, I'm stopping. Okay.
Mute yourself maybe. Threshold, and then just find if it is.